All right, welcome to the Explainer. Today, we are tackling a classic coding problem, one you see all the time in technical interviews, and we're going to solve it from the ground up. So picture this. You have a massive, nonstop stream of numbers just pouring in. At any given moment, someone could ask you for the product of the last 10 numbers, or the last 1,000, or even the last million. How do you give them that answer instantly? That's the challenge we're cracking today.
Okay, let's break this down. We're talking about the product of last k numbers. What we're really trying to do here is understand the core challenge, building a system that can handle a constant flow of data and give us answers in a snap.
What we need to build is a class. We'll call it product of numbers. And it really only needs to do two things. First, it needs an add method. You give it a number, it adds it to the stream. Simple. Second, it needs a getProduct method. You ask for k, and it has to spit out the product of the last k numbers it's seen. Seems easy on the surface, right?
So faced with that, what's the first thing you'd probably think of? Let's talk about that simple, slow approach. You know, the first idea that comes to mind. And honestly, this is where most of us would start, and it's a great place to begin.
The logic here is pretty much exactly what you'd expect. We'll just store all the numbers in a list. When a new number comes in with add, we just pop it on the end of the list. Done. And to get the product of, say, the last two numbers, like from a stream of 3, 1, 2, 5, 4, you just grab the last two, the 4 and the 5, multiply them together, and you get 20. Easy enough.
But, yeah, there's a huge catch. We hit a wall, and we hit it hard. While that add function is super fast, our product get function has a major performance problem, especially as that stream of numbers gets longer and longer.
Here's the critical issue. The calculation time is completely tied to k. If you ask for the last 5 numbers, that's fine. But what if you ask for the last million numbers? Our code has to do 1,000,000 multiplications for one single answer. That's what we call O of k complexity, which in the worst case is as bad as O of n. That's just not going to fly. We need something that's always fast. We need an O1 solution.
So how do we get there? This is where the magic happens. We're going to use something called the prefix product trick. And trust me, this little idea is the key to unlocking those instant calculations. It completely changes the game.
Now, this trick might sound a little familiar if you've ever worked with prefix sums. With prefix sums, you pre-calculate a running total, and then you can find the sum of any range with just one subtraction. We're going to do the exact same thing, but instead of adding, we'll be multiplying. And instead of subtracting, we'll be using division.
Let's actually build one of these arrays. We always start with a 1. Think of it as our base. Okay, first number in our stream is a 3. We take the last number in our array, the 1, multiply it by 3, and append the result. So now we have 1, 3. Next, a 2 comes in. We take the last number, 3, multiply by 2, and append 6. Now we have 1, 3, 6. Finally, a 5 comes in. 6 times 5 is 30. Our array is now 1, 3, 6, 30. It's a running product.
And this is the whole point. We have this special array. So what? Well, say we want the product of the last two numbers, the 2 and the 5. All we have to do is take the very last product in our array, which is 30, and divide it by the product from 2 steps ago, which is 3. And what's 30 divided by 3? It's 10, which is exactly 2 times 5. We got the right answer with a single division.
And boom, just like that, product is now O of 1. Constant time. It is incredibly fast. It doesn't matter if you want the product of the last two numbers or the last 2 million. It's always just one division. This is a massive win.
But hang on. We're feeling pretty clever right now, right? Our solution is elegant, it's fast, but there's a hidden trap. A single, innocent-looking number that can bring our entire beautiful system crashing down.
You guessed it. What happens if a 0 shows up in our data stream? This is the kind of critical edge case that interviewers absolutely love to see if you can catch.
Let's trace it out. Our prefix product array is 1, 3, 6, 30. The next number to come in is a 0. So we follow our rule. We take the last product, 30, we multiply it by 0, and we get 0. So we append that, and our array becomes 1, 3, 6, 30, 0.
And you can probably see the disaster that's about to happen. From this point on, every new number we add will be multiplied by the last element, which is 0. So if a 5 comes in, 0 times 5 is 0. Then a 4 comes in, 0 times 4 is 0. The 0 acts like a poison, just wiping out all future information.
Yeah, it's completely broken. Our whole clever system is useless now. We can't divide by 0, and all our future products are wrong anyway.
We've lost all the useful information we had.
But don't worry, it's not hopeless. There is an equally elegant fix. We can handle this zero problem with one simple, clever rule. This is the last piece of the puzzle for our final, fast, and robust algorithm. Here's the rule. If the number you're adding is 0, you just hit the reset button. That's it. You forget everything you've calculated so far, we throw away our prefix array and just start a brand new one right back at its initial state. 1. The 0 basically draws a line in the sand. Okay, but that reset brings up a new question, right? What if someone calls getProduct with a k that's so large it's asking for numbers from before the 0 happened? Our new array is really short, so what do we do? And the logic here is just beautiful. If the k you're asking for is bigger than the size of our current array, what does that guarantee? It guarantees that the range of numbers you want must have included that 0 that caused the reset. And what's the product of any set of numbers that includes a 0? It's always 0, so we just return 0. Problem solved. And here it is, the whole thing in one simple table. This is our complete, battle-tested algorithm. For add, we check if the number is 0. If it is, reset to 1. If not, we just multiply and append. For product get, we check k is too big. If it is, the answer is 0. If not, we do our one super fast division. That's it.
And the final performance is exactly what we set out to achieve. The time complexity for both add and get product is O of 1, constant time, blazingly fast. Now the trade-off is the space complexity, which is O of n, because we have to store that list of prefix products. But that is a price well worth paying for this kind of speed.
So there you have it. We started with a simple idea, found an elegant optimization, and then made it robust by hunting down and solving that tricky edge case. So the final question I'll leave you with is this. What other problems could be solved with this kind of prefix trick? It's a really powerful pattern. Keep that in mind, and we'll see you on the next explainer.